Good afternoon. And hello. Well, hello to the folks who are watching on Twitch. Nice to see all of you. Oh, we got a bit of Twitchception going on there. That should be over there. That should be over there. That's better. I'm just trying to work out. I think the YouTube stream here is having a difficulty. If there's anyone out there who is watching this right now on YouTube and it's working, give me a shout, because from where I'm sitting, it looks distinctly like it can't find a stream setting. So let's take a look here. And that's all part of the fun, you know. So that's alright. That says I'm online. That says I'm online. And ooh, there we go. Yep, it's fine. It's nice. Ah, it's yes. Hello, Johan. So I made a mistake of trying to do something clever, which was to try and work out how to use the events thing in YouTube instead of running everything just as a random ad hoc stream. Yeah, it would appear that I did not quite get things plugged in quite the way I thought it would. So I think we're good. I think we've got people on Twitch, and I think we've got people on YouTube, and of course I'm not doing it for the people. I'm doing it because, you know, Art of Code, and it's fun and interesting to try and solve it every day. But let's kick things off and see how we get on. Let me just give that a little bump. That's nice, and that's fine. And the top of my head is getting cut off. Look at that. Ah! They warned me this might happen. So Tsanal says today was great. Hello, Tsanal. Good to see you, man. Well, we'd better have a look at it then, hadn't we? So let's fire it up and see what we got. Advent of Code 2020. Day 24. I had a very quick look at this. I got as far as hexagons, which at the moment that's as far as we got with it. So we've got a turns out the small crab was an excellent navigator. Well, that's nice. As you enter the lobby of your resort, you discover a problem. The floor is being renovated. You can't even reach the check-in desk until they've finished installing the new tile floor. The tiles are all hexagonal. They need to be arranged in a hex grid. So let me just fix that. That's nice. In a very specific color pattern. The tiles are white on one side, black on the other. They start with the white side facing up. A member of the crew gives you a list of the tiles that need to be flipped over. Each line identifies a single tile by giving a series of steps starting from a reference tile in the very center of the room. Because the tiles are hexagonal, every tile has 6 neighbors: east, southeast, southwest, west, northwest, and northeast. No north, no south. Alright. The directions are given as E, S, E, S, W, W, N, W. Okay, so that's interesting, because we never get an N on its own or an S on its own, and so any S or an... Okay, there's a prefix, like a Huffman-style prefix code. Alright, that's okay. A tile is identified by a series of these directions with no delimiters, so blah, that's your data. And blah is more data. That's nice. So each time a tile is identified, it flips from white to black or from black to white. Tiles might be flipped more than once. Well, this is entertaining. So... Okay, so what makes today particularly interesting, just looking at it here, is hexagons. Because the hexagonal data, it might be easy to think, all right, we'll start in the middle and we'll just, every time we see a hexagon, we'll plug a hexagon in there. Hello, Marty. Welcome. How are you? We're doing stuff with hexagons. So yeah, the fact that the data structures are hexagonal, I've run out of Advent of Code paper here. Let me grab another one. There we go. That's the sheet music to a little town of Bethlehem. I'm a very easily entertained person, Johan. Entertainment is kind of, yeah, if you're not entertained, you know. Right, so let's take a little look. So we've got, have I got my paper cam here? Ooh, look at that. Okay, that's nice. Ooh, that's a little zoomy. Let's just check the zoominess on that thing there. That's up here, and we zoom out a little, and there we go. That's nice. So we've got a hexagon, but we potentially have an infinite grid of these things. Now they got east and west, haven't they? So now the interesting thing about the hexagon structure, is, so we could potentially model this as a massive two-dimensional matrix of cells, right? Because I'm just trying to think through the thing that makes it difficult. So we could just go, right, say this is our reference cell here, and we gotta go northwest, so northwest is there, that's northwest, and then we gotta go west, which is there, and then we gotta go southwest, which is there, and then we gotta go east, and we gotta go east, and we gotta know that we ended up back where we started, which means this thing needs to be some kind of a map. Now, let me bring this, sorry, thank you, Marty. Let me fix the thing here. Yeah, there we go. And that should be behind there. Ooh, there we go. That can probably do with being a little smaller. There we go. And that could probably do with being a tiny bit smaller as well. There we go. I've been tweaking the parameters, as you can tell. Yeah, so, all right, that'll do. That's nice. So yeah, we got this arrangement of hexagons, which actually, what you can see here is the 4-part music for Little Town of Bethlehem. Now, if we build this thing as a an array, because there's a way of saying, like, let's treat each one of these as a row, okay? And so we've got a bunch of cells here that are like, hola, Bernardo. Now we've got, so okay, what I'm trying to figure out here, let me fire up Visio, because I like it, because Visio is super awesome and brilliant for doing stuff, but also it will let us very quickly throw a whole bunch of hexagons onto some kind of a screen and see what they all look like. So let me spin that up and that up and that up there. So there we go. You can all see that. That's nice. So we've got a hexagon, and the hexagons in our puzzle, they are 30 degrees off from that, aren't they? So we got a whole bunch of these things, and I'm just gonna kind of arrange a bunch of these like this and this, and of course grid systems don't work too well with hexagons because computers work in squares, not in triangles, unless you're doing kind of vertex modeling in 3D. But this is probably close enough for what we need here. I've screwed that up, haven't I? These are not the wrong way around. We need that whole thing to be 30 degrees. No, we need it to be like that, because they've all got, yeah, they got east-west. That's it. Let's play Blockbusters, if anyone recognizes that reference. So we got a whole bunch of these. Now, what I'm trying to figure out is if there is any abstraction that will let us model a set of hexagons as a two-dimensional array of cells, because you could theoretically say, all right, let's say that's so this is row number 1. So we've got the whole problem again where we're starting in the middle, which is going to make this even more entertaining. So we've got a So the problem, Will, I was thinking it could be a 6-linked list, right? That's definitely an idea that I was playing around with. But then the difficulty with doing a 6-linked list is how do we kind of, let's say that we get the, of course, now I've got this in Visio, what I want to be able to do is to scribble all over it. It could be a graph structure of some sort. But what I'm thinking is that maybe we can do it as some kind of... So imagine we've got an array whose elements are 1, 2, 3, 4. Actually, this will be 0, 1, 2, 3, 4. And this will be... hey, Adam, how you doing? This will be 0, 1, 2, 3, 4. And this will be 0, 1, 2, 3, and so on. 4. And so that, now what I'm thinking is does this thing give us a consistent set of rules for any cell? So if we want to move, yeah, I think it does, you know. So for any cell now to go east, which is that direction for me, we just, so let me grab an arrow here. I should have somewhere arrows, more shapes. General arrow. Where's my arrows gone? Maps, general, basic shapes. There should be arrows in here somewhere. Arrow shapes, that's what I'm looking for. Alright, so starting with any arbitrary shape. To get from that shape to... No, do not lock to things, please. Just let me drag that whatever I want it to be. So to go west... It is, we say this thing is a grid of rows and columns. It is column -1. To go east is column +1. Yeah, I think that'll work. Yeah, maybe. Linked list would be a way of doing it. The reason why the linked list thing sort of slightly worries me is that we've got this thing where if we end up kind of going around our graph in 2 completely different directions and ending up on the same cell, we need to know that. And unless we've rooted, kind of built every single, like grown the graph like this as we go along, so that it's constantly expanding, I can't see how that's going to work. But I do think we can model the hexagons as a array of elements such that for every cell we can get an adjacent value from it. Yeah. We can get an adjacent value from it in a way that is consistent. For any given cell, west is subtract the column, northwest is subtract the row only. The nodes could keep track of how many times they're flipped. Okay, so the reason why I'm pausing here, let me grab a fresh sheet of paper for this. So if we've got our... Right. So. Right. So here's the thing. We start with our cell in the middle, right? So that is cell A. Then we go, say we go to the east. So that is E. That gets us to this cell here. That is going to be cell number B. Then we go east again. Gives us cell C. Then we go northwest. That gives us cell D. Then we go west. That gives us this cell here, which is B. So that's east, that's northwest, that's west. So that becomes cell E. All right, now so that move there is E, northwest, west. Okay? So Adams just said there's a couple of ways. The initial idea was X and Y, adding X, subtracting X. Yeah, X plus 1 on northeast. Later I found out it's called doubled coordinate. Okay, cool. So the thing I just invented in Visio has a name. Now the thing, so we build a linked list as we go along, and we know that, for instance, A is there, and we start assigning some. So if that's there, then we say B's west is that, C's west is that, D's northwest is southeast, E's, that's west, so we build the east there. But then let's say we have another one. Again, we're starting from A, because we always start from A. But on this second one, we are going to go west, west, north, west, northwest, east, east. Okay, so we go west is there. Then we go northwest is there. Then we go east is there. Then we go east and we get to... But how do we know at that point, when we say move east, what data structure exists that tells us, oh no, you found that cell already. That one already exists. Now, I can't see a way of doing that with a linked list unless you build the entire grid in the beginning. I may be wrong. This is, as you know, the things I'm doing here on Advent of Code. A lot of it is just watching me be wrong and be wrong and be wrong and go, that's interesting. That's not what I expected to happen. I didn't understand that. I've never heard of that. And finally get to, that little moment of enlightenment. Or sometimes just the moment where it spits out the right answer and we don't know why. But I think the solution that I'm going to do is I'm going to plug this in as a... model the hexagons as a doubled coordinate system. And I'm going to do today in Visual Studio, because yesterday I did in JavaScript. JavaScript is a lovely language, and it's amazing, and I love doing cool things in a browser. I did not have a huge amount of fun yesterday with Node.js. It took about 20 minutes of trying to get the syntax right for it to... you need a set. Adam says you need a set of XY array of 2 elements. Why list? I think I may have answered that question already, because I'm just going to build a big 2-dimensional array and map everything in that. So anyway, let's create a new project. And as we've done previously, I'm going to do it with NUnit, and I'm going to do it with ncrunch, so we get that kind of nice. I want this in D projects, GitHub, Advent of Code 2020, day 24, and it's going to be called day 24 tests in the day 24 solution. Day 24, I can't believe it. Like, wow. December has flown. Like, between doing Advent of Code and blogging every day and planning internet parties and preparing for stuff, December has absolutely flown by. How do we know up front how big the array is supposed to be? That is a good question, because we can either build a data structure that... So my hunch here is we build a really big array and we start in the middle. So what I was gonna do, Will, is actually that's a. Let me just double check the requirements here. So they just want to know how many tiles are left with the black side up. Now, it might say in part 2 you need to remember how many times they get flipped, but for this one, I think we can get away with just saying ones and zeros. And we can bound it by the length of the longest instruction. Let's have a look at my input. How bad does that get? Okay, so the longest instruction that we got. This thing is a 1 or 2 character encoding. Yeah, we can bound it by... We know how big the playing field has to be because we know how many moves. Yeah, so Marty and Sarnal on the chat have both just observed the same thing, is we know the longest sequence of moves we're going to have to make. And so we can bound our array. Now, we could do that. Hey, Mohammed, welcome to the stream. How you doing? We could do that whole thing by building some kind of calculator, but to be honest, looking at the input, I'm just going to eyeball it. So we got a bunch of stuff. That looks about as long as it gets. So we build that plus a little bit. Now that is about, what, 32? So I reckon if I make a massive array of like 128 by 128 things, that should give us enough room to play with. So I'm going to do public class. What do we call a lot of hexagons together? We call it a beehive. Because that's what... Actually, it's a honeycomb, isn't it? Not a beehive. Public class honeycomb. And so a honeycomb has the methods that we are going to need to get out of this thing are... we need to run a flipper tile based on a series of moves. So this is sketching out the shape of the API that I want to be able to run my code against. No, because a beehive isn't 3D, because a beehive is just layers of comb. We're not actually, if you go with a, what's the platonic solid that extends the decahedron? No, not tetrahedron, not an isocahedron, but there's a tessellating platonic solid which has a similar behavior, like the way if you extend triangles to tetrahedrons, or if the way you extend squares into cubes, you can extend hexagons into something else, and then you get a three-dimensional shape that has this weird north, south, east, westy kind of behavior to it, which is kind of cool and funky. All right, so the methods that we want to be able to run on here are, we want to be able to void, what did they call these things? Flip tile. So let's do void flip tile, and this is going to take a string. What did they call that thing? Each line gives a series of steps, so we'll call that steps, okay? So we're going to be able to flip a tile by giving it a series of steps, and that tile is going to flip. We want to be able to count the number of tiles which are flipped. So public void flip tile and public int count black tiles. The tiles are all white to begin with, correct? Tiles are all white on one side. They start with the white side facing up, and the lobby is large enough to fit whatever pattern might need to appear there. So public int count black tiles get is going to return. We don't know yet. Let's say that's going to return 0. That's going to do nothing. So we don't need any setups here. So let's start plugging in some code. And then the last thing we can just test this. You can't platonically solidify hexagons because 3 times 120 equals 306. Ah, yeah. Yeah. So what's the shape I'm thinking of? That one. I'm thinking of the icosahedron. Icosahedron. Wow, what website have I found? Cool. Plato was a dude. All right. Anyway, yeah, let's go back to writing programs about beehives and stuff. So the behavior that this thing is actually looking for here, in theory, we like the state of individual tiles is not required here. All we need to know is, so let's say var hc equals new honeycomb, and I'm just gonna, I want to plug in Shouldly and enable ncrunch. Install package Shouldly. There we go. And then enable ncrunch, and we get little green traffic lights next to all my code, and if any of them go red, it means we've made a horrible mistake. Or probably a relatively small mistake in the grand scheme of things, because it's the advent of code and it doesn't matter all that much. So we got hc is a new honeycomb, hc.count black tiles dot should be 0. Actually, that can just be black tiles. Count black tiles to me is active. It says run code, does something. It should be a method. Let's make it a method, just for the sake of what we're working on here. Count black tiles should be 0. So take that out. Take that out. Okay. So there we go. We have green test. Right. Let's write a failing test. So test public void flip one tile var hc equals new honeycomb hc.flip tile e hc.count black tiles dot should be 1. Now we could go with the militant school of test-driven development here. But I'm going to plug in, so what's the simplest line of code that is going to make this thing work is... there's always a tendency with this kind of things to be a little bit kind of perverse and bloody-minded about how to interpret write the smallest amount of code that's necessary to get the test to pass, that tenet of test-driven development. Because I could, for example, put a line of code in here that says, all right, private int black tiles equals 0. Flip tile black tiles plus, and that could just be return black tiles. And when I do that, all my cup tests are going to go green. Boom, there we go. All right. So now let's write another failing test. So test public void flip one tile twice. So var hc equals new honeycomb hc.flip tile, and we're going to go west, and then we're going to go east, and then we're going to say hc.count black tiles should be 0. No, it should be 1, but then we do it. Ooh, no, do that, and then that, and then black tiles dot should be 0, because in each case we start at the origin. So for every move we start at the origin tile and we work our way out. So that's gonna work for that one. That test is now failing because at this point we probably need to implement some actual behavior. So I'm gonna say public class honeycomb, and I'm just gonna throw in an int size here, and I'm gonna default that size to be 128. It's probably big enough, but we can make it bigger if we need to. So I'm gonna say var cells equals new an array of boolean import system. How did I not have system.boolean? Size. So that should give me a nice big array of all those kinds of things. And then count black tiles is going to return cells.count. That needs to be a property. Is flip tile dealing with one tile? Each invocation of flip tile flips the same tile, or each invocation starts at initial position. So flip tile here, each invocation starts at the initial position. So when I say flip tile, that always starts. What I'm going to do, though, the way that I'm going to build this thing, Adam, is to grab my puzzle input, and I'm going to feed each of these lines into that method. Oh, apparently nini nini swinini is chosa for nini nini ni swinini, which is nice. I'm glad we've cleared that up. All right, good. Good effort, Google. Thank you. Yes, I'm going to feed each of these lines to flip tile, and then at the end I'm going to see how many tiles got flipped. Back over here, private boolean ding cells. That's fine. Cells equals new boolean size y. Is that complaining it can be read only? That's all right. That's gonna say, yeah, okay, flip it. We'll use bool instead of boolean. It involves less typing. So cells.count cell to cell. Now this is interesting. What is a multiple dimensional array? Because an array in .NET is an IEnumerable. But I don't know if a multi-dimensional array is. So C# multi-dimensional array link. Yep. Isn't a list of black cell coordinates enough to solve this? Maybe? Your map is a multi-dimensional array. These do not see... why does C# multi-dimensional arrays not implement IEnumerable of T? Okay. Yep. All right. A list of coordinates is enough to do it, or we just need to know, which cells are currently true. So if I cast, what do we get if we cast a list to for var x equals a row equals, now we can do xy. Not x is less than cells dot length, get length 0, x plus plus. For list is going to work, but more slowly. Hash set a point where point int x int y. List is going to work, but more slowly. Is this because you know that they're going to give us a 10 million bajillion in part 2? Because I'm going to solve part 1 this way, and then I'm going to look at what we got to do with part 2. For var y equals 0, y is less than cells dot get length 1, y plus plus. So var count equals 0 if cells x y count plus plus. All right, and return count. Okay, so now we need to implement the flip tile logic here. So flip tile is gonna need to yeah, you're gonna if the address XY is black, the rest is details. Black is true, white is false. So black tiles is there, flip tile is gonna be fine. That line we do not need. So that first line, that rule's true, but it's flip tile and flip tile 2. Those are working. So private int map coordinates map coordinates string steps. So we want at each point here, so what do we want to do? We want to pull the next token off the steps sequence there. So yeah. Dictionary, index, int y, bool. Yeah, no, this is fine. We're good. So what do we got? Let's just take a little look at the rules we got in there. So if I make this thing here public, int map coordinates, string steps, that should be fine. Let's return 0, 0 from that. And public int map coordinate string steps. So I want to throw some testing in around that. So test, and then I want a test case here that says if the cell is west, we are expecting those coordinates to return a so what is that's going to be -1 and 0. Public void check coordinates for steps, and this is going to take string steps, and it is going to take a int tuple, so a pair of ints, which is expected. Now remember, this is not absolute coordinates, this is offsets, so this can bring back stuff that's negative. Why is that complaining? An attribute argument must be a constant. Can we not pass in tuple values in that? Is tuple literals not allowed in C#? Whatever. All right. I've been doing too much JavaScript. .NET tuple literal in attribute value. Boom. Yeah. All right, never mind. We'll do it this way. Int steps, int x, int y. So var. So those are our expected values, aren't they? So I'm gonna call it expected and ypected because I can. Because why not? So var x, y equals, we need to spin up a new honeycomb. Var hc equals new honeycomb, which we shouldn't be doing in every single test case, but it's cheap because honeycomb is really cheap at the moment. hc.map coordinates on steps, and x.should be expected, and y.should be ypected. West and northwest, southwest need to get same coordinate. No, should be fine. So the way I'm modeling the grid, if we go back to the paper here, so this is cell A. So that there is, so this one here is, say that's 0, 0. That's x and y, so that's 1, 0. That'll be 0, 1. That'll be 1, 1. So that one there, the x coordinate, which is the 1 here, needs to be down to 0, and the 1, 1 stays the same. But let's just check. I'll build the test cases for all of the individual scenarios here. So west is -1. East is +1. Northwest is -1, -1. Northeast east is actually no, northwest is just -1 in the x-axis. Northwest is just -1 in the x-y axis, so that moves up a level because I'm sloping my coordinate system that way. That northeast is gonna go from that to, so it's gonna add 1 to that and -1 from the y coordinate. And then the southwest is gonna have to 1, 0 goes to, so that's our -1 on that one, +1 on that one, and southeast is gonna be +1 on both axes. Okay, so those are our single step coordinates. Okay, and that's not working, so let's implement a parser. So we want to go with flip tile goes to map coordinates. That's void, so it does nothing. So map coordinates here. We want to switch on. We need to build a parser that can consume 1 or 2 characters here. So we're gonna switch on steps dot. I want a way of pulling the first element off that array, or consuming the first element of the steps thing there, which is push pop string doesn't work. That's all talking about stacks. I now wish I'd done it in JavaScript, which I deliberately didn't do because yesterday that was complicated. So let's grab the switch on steps 0. So case E. Return, so what did we say we want? If it's east, we return 1, 0. That's fine. Case W. Now that's gonna be a char because step 0 returns a character taken from a string. That's gonna return -1, 0. Okay. Map coordinate, that not all code path, so at the moment we can't actually compile anything. Yep, so the number of failing tests is, you see these 2 lines are green now, they're covered only by passing tests, not failing ones. So case if the east, so if it is north, then we want to return steps 1 equals W. So we could do it, we want to switch into a, I just can't think of a nice way of doing this. So NW should be 0, -1. Otherwise, the thing is an NE, so it is 1, -1. And we can simplify that a little further by saying that's a 0 or a 1. That's fine. So that's actually just the first element of the tuple now. Steps that equals 0, otherwise 1 and -1. And then case S, we want to return -1, so it's a +1 in both cases, but it's a -1 or a 1 in the first instance. -1 if we're going west, 1 if we're going east. So steps 1 equals west, -1 if we're going west, 1 if we're going east, and return a 1. That should give me green across the board, apart from the flip 1 tile method. So let's plug in some extra tests, because these are only checking for a single step now. So I'm going to rename that method to be check coordinates for steps. So plug in another test case here, which is if we go east-east, we are expecting 2, 0. Plug in another one here, which is if we go west-west, we are expecting minus 2, 0. East equals 1, 0. Yeah. Northeast is 1, minus 1. Northeast is... Yeah, northeast is incorrect. X is 1. No, that is correct. Southwest. East equals 1, 0. Yeah? Northwest. We go back to the paper here. I'll bring that across so we can see them side by side. On our hexagon grid, so these are our coordinates. We got 0, 0. We got, so X is 1, 0, 2, 0, 3, 0. And then next row, we've got, so these look like this. So 0, 0, and then the next one down is, so this one is X's, so that's 0, 1. That's 0, that's 1, 1. That's 2, 1. That's 3, 1, because our coordinate system is X and Y. So Y is the second one here. So for this coordinate here, 1, 1, east is X goes to X plus 1. So east there is add 1, 0. So 1, 1 plus 1, 0 equals 2, 1. 1, 1 plus minus 1, 0, which is west, goes to, 0, 1. Northwest, which is this one here, 1, 1 needs to be subtract 1. So northwest is 0, minus 1. Northeast, we want to subtract 1 from the X and add 1 to the Y. So northeast should be plus 1, minus 1. Southwest is that direction there, and this cell here is going to be 0, 2. So southwest should be minus 1 plus 1, which it is, and southeast is going to go from 1, 0 to 1, 1 to, this one's going to be 1, 2. So we want to add 1 to southwest, should be 0 plus, minus 1 on the, hang on. Southeast should be, no, it should be, maybe there's a problem here. Southeast equals 1, 1. Yeah, southeast needs to be 0, 1. Yep, you're absolutely right. Southeast needs to be 0, 1, opposite of 0, where. I'm going to put these in coordinate pairs. So southeast is the opposite of northwest. West is the opposite of east, and northeast is the opposite of southwest. Yeah. Okay, I think that makes sense now. So east should be 2, west should be minus 2. Test case. Let's plug in another one. So so east west should be 0, 0. Let's get that one right. East west 0, 0. And northwest to southeast should be 0, 0. Northeast southwest should be 0, 0. Should keep us going for now. So in .NET, can we add tuples together? What is 1, 0 plus 2, 2? Can I apply? Okay, so we can't do matrix arithmetic operation-y stuff, which is slightly annoying. So I'm just going to do this as a loop for now. Int I equals 0, so that's the index that we're at. And then while, and then we've also got int x equals 0, int y equals 0. Cheers, Johan. Take it easy. Enjoy. I is 0, x is 0, y is 0. We can probably flatten those into something. Yeah, that's nice. That's never used. Okay, so while I is less than steps.length, switch steps I++. And case east, return that. Case west now. So case east here, x++ break. Case w, y minus minus break. Case n, we then need to switch on steps I++ again. And at this point, case w, so that if it is so if it's north, then y always gets decremented, and then we switch on the next one to see whether it's northwest or northeast. Case and only if steps I++ equals e does x get incremented. But that doesn't need to be a switch because there's only one case for it. So if steps I++ equals e, x++, break out of that, and finally if we are going south, y++, because we always decrement there, y++ goes down, and if steps I++ equals but this one we need to do something in both cases. So 1 equals west. X minus minus else x++. Okay, that wraps on that, wraps on that, that's on that. Break there. Why is that complaining? Only assignment call increment and okay, never mind. It does not want us to just do that like that. Because C# things have to be things. They can't be. So if we now just return X and Y out of that. Will it build? One succeeded. Will it run? That's interesting. Yeah, so that breaks out of there, that breaks out of there, that breaks out of there. I should be incrementing every time. That needs a rebuild. I accidentally threw in an infinite loop at some point that I think the testing engine has choked on ever so slightly. Not a lot, just a little. All failed. Why have they all failed? X should be 0, but was 1. They are. That's weird. Yeah. Yeah. So. Okay, they're not even working. All right, let's break this thing back down. Let's do it one by one. Test case by case. And I'm going to comment out that test for now because it's not going to work until we got the rest of this working. All right, so none of that is currently working. So case east, case west should be at x minus minus. Case n, y plus plus. There's something missing from the coordinate system here. So I found what was definitely a mistake there. So the test that is now failing is northwest, southeast, 0, 0, and northeast, south, and then east should be returning 0 and 1. So south and east, 0 and 1. So south, we always increment, yeah. Southeast, move south and east should be, the y gets incremented, but the x does not. There. No. Yeah. Both north and south have a case where y doesn't change. So north, you only bump. Needs to be that one. So yeah, north you only bump the x coordinate if you're going east, and south you only bump the x coordinate if you're going west. There we go. All right. That appears to have settled in. If I do this, is it going to preserve it when I do a code reformat? Yes, it is. Right, okay, so we've got our input, we've got our parser, we've got our honeycomb, we've got our black tiles, we've got our flip tile, so I'm just gonna do a const int origin equals 6464. Is that going to let me do that? No, because the type int cannot be declared constant. Okay. So x64 and y64. We need to do that, don't we? X and xy origin equals that. Make them big X and big Y. So var offset equals map coordinates on steps. Var X equals offset dot, and that's going to return an int X and an int Y. Name the elements in the tuple. Offset dot X plus origin dot X. var y equals offset dot y plus origin dot y, And their cells x, y equals not cells x, y because they are Boolean. So we should just be able to flip them. That comes out because we don't need that. Our cells are in, that's fine. Make origin read-only. Have I uncommented all test cases? Yes, all except this one, which is now working. Yeah, no, they're all good. So let's flip one tile. That's fine. So now we want to add in black tiles. No, that's just a hangover. That's not happening anymore. So offset can be okay. Interesting. We can deconstruct that. Actually, let's just do that. Var x and y, and then we can have x plus equals origin.x, y plus equals origin y, and then cells xy gets flipped. Okay, tests are green. We've got what I think is the guts of a pretty good implementation. Last thing that we want is to plug in a new method on here, which is public void flip tiles string moves steps list. There are some test cases in the problem description that we can well, kinda, not really. I'm gonna plug in this one here, but that should give us 10. So what we're looking for here is string steps for each. So var steps in steps is yeah, no. So Oslo, you're talking about this one here. We want to increment the pointer every time because so steps I++ here, we need to consume the next character in the input, which is either an E or a W. But it's only, we could break that out, and we could say like var char next equals, but because we got this case where if the next character is W, we do still need to consume the next element of the input, even though we discard it. If we see an N, we always need to eat the next thing as well. N's don't occur on their own. It is, yeah, the code could be written a lot clearer. This chunk of code here is a little bit gnarly, and I would probably build some kind of, if I wanted to make this very, very clear, I'd build a tokenizing parser that consumes the next token from steps, which will be either E or W or NE or NW, so the tokens there will be the different coordinate systems. But yeah, you're right that it looks a little bit gnarly, but I do not think it is a mistake. I think it is correct. Flip tile steps. This dot what? Okay, that should be fine. That should be alright. Var steps and steps is this dot flip tile. It doesn't like that. I hate the thing in English where there's no distinction between, like you can have sheep, and you can have sheep, and you can have a flock of sheep, and you can have flocks of sheep, which means that each flock in flocks is sheep, and each sheep in sheeps, but a flock is technically equivalent to sheeps, but sheeps is not even a thing. Steps is gonna stay in there. Actually, I'll make that list. That'll just that's nice. For each var thing in list, this dot flip tile steps. So, and that should be okay. So we now want to plug in another test here. So public class test, public string. Hello, Louise. A virtual wedding? That sounds terribly entertaining. Boom, there we go. Let's grab that. We don't want that. That should be public cast test, public string. Let's just make that const string example equals that. This is going to blow up now because environment.newline is not constant. Believe it or not, that is not a compile time constant. Code in .NET doesn't know what newline is at the point where you compile the thing, unless you accidentally capture it inside a string. So that's fine, that's nice. So I just want to throw in another test here, which is test public void test on example input var hc equals new honeycomb. Does anyone else want a crunchy with all this talk of honeycomb? I could really eat a crunchy right now. hc.flipTiles example hc.countBlackTiles should be 10. Green, boom, look at that. That is fine, it worked. Total of 10 tiles are black. So, go through how many tiles are left with the black side up. So let's save my input. Newline should depend on the runtime. Yeah, no, you're absolutely right. It is, but it depends. Is it the environment where the, because one of the things that messes me up sometimes is where you have a resource like a string file, which is compiled into your assembly on the platform that did the compilation, but then if you try and split that string file on environment.newline, you get the newline that came from the runtime environment, not the compile time environment, which is a massive kind of headache if you're using plain text files as part of, test fixtures or any of that kind of stuff. So there's Advent of Code 2020. What are we on? Day 24 tests, input.txt, Visual Studio, input.txt, copy always. That's nice. And let's do a test. Public void solve part 1 var hc equals new honeycomb hc.flipTiles file.yes .read all lines input.txt. No, there, thank you. hc.countBlackTiles should be, well, I give it anything and it'll say test failed because you got the wrong answer, because your actual answer was 473. So over here, down into that, submit that. That's the right answer. Continue to part 2. Conway's Game of Life in hexagons. All right. "100 days. Yep. Okay, Sully, right. So I'm going to start by grabbing what I got here and just doing a quick git commit on that in case we want to come back to it later. CD projects, CD GitHub, CD Advent of Code, git add, all the things, git commit -m, day 24 part 1 in C#, git push, boom. Okay, well this is exciting. Okay, so let's get crunchy. That was not a pun. that I must just have the word crunchy on the brain here. So that was 473, wasn't it? Expect that should be 473. Grab that. That's all fine. That's nice. So we need to now completely rebuild the way our honeycomb works. So this is not a bool anymore. Public class cell. So public cell belongs to a honeycomb HC, and that means this dot comb equals so public cell honeycomb, this dot comb equals HC. That's fine. Public honeycomb comb, this dot comb equals HC. So now we got a bunch of cells. We got so public bool, well, it's black and white, but it's a living or dead kind of thing, isn't it? Public bool is black. This will be private bool is black. That's fine. I'm just gonna call it no, we'll go with that. We'll probably go with that. That's all right. Public bool is black. Get return is black. That's all right. Public bool will be black. Next time. I just need to expose it somewhere. All right, we don't need that. We don't public bool. We'll go with just state on it. All right, public bool state. Yep, set. Okay, that's fine. Private bool next state equals. We'll pick that one up in a second. So we need to public cell west get return these cells need to know. Okay, so there's another potential way we can do this. Instead of implementing a cell as a class in its own right, we could have a function that runs the entire honeycomb and tells us what the next iteration of the honeycomb is going to look like. We can have a stable comb of cells that flip each time, or we can have a yeah. And again, the tile floor is meant every other tile roll flipped. Any black tile, okay. So this thing starts. What's the starting state? Is the starting state our input? Is the starting state our answer to part 1? Okay, that's not... Yeah, okay, so that's not made explicit here, but never mind. Yeah, okay, so the state at the end of part 1, that's where we start from. And then we run a game of life on it a whole bunch of times. Hey, okay. So, what's a nice way of plugging this slot in? I'm not going to do this. I don't want to build a cell. That's boring. I don't want to do that at all. I want to add a method to this, which is going to be a... so, first of all, we need a public int count. Black tile with 0 and 1, 2 black tiles. Any white tile with exactly 2 black tiles. Any black tile with 0. So, I need a count adjacent black tiles. I am not writing a function called count black neighbors because this is not a sitcom from British television in the 1970s. Count adjacent black tiles. Any black tile with 0 and 1, 2. Okay, so we just need a thing in here. So, and this is gonna take, we're gonna take int x and int y. Now we've already calculated these 6 offsets, right? So, is there a way? Is it easier just to reinvent the wheel, or can we just go? For var offset, for var direction in new, so this is gonna be west, east, northwest, northeast, southwest, southeast. Except I'm gonna do var offset in for each var offset in new. That I'm gonna grab up and stick in here. Const string directions equals that. Put them into a dictionary and use in your parser. Yeah, that's exactly what I'm doing here. So it doesn't even need to be a dictionary. For offset and directions dot select D goes to map coordinates D, which can be crunched to a method group. That's fine. And then I want to say if cells x plus offset dot x, y plus offset dot y. So int count equals 0 can be a var count plus plus. Yep, that's fine. That's nice. And I could actually go even further, and I could say this thing is int x, int y, directions equals that dot select. So I'm not needing to do the select every time. That needs to be static, so I can grab it from there. And that should... Why is that complaining? Cannot resolve symbol. Why can't you resolve the symbol? Because I haven't closed the method, that's why. That needs to return the count, that's fine. For var offset, that is... I might be doing some stuff here with C# that you are not supposed to do. Or I might just missed a bracket, of course. That's the other thing that might have happened. Map coordinates cannot be referenced, so that is just going to be xy equals honeycomb dot map coordinates. So that doesn't even need to be a thing anymore. Look at that. Ah, that's beautiful. That's nice. That's so nice. And we can be even gnarlier by doing that. Look at that. Look at that. Look at that. Oh, I love it when you can do stuff like this. So that says grab every offset and plug that into the cell with x plus offset x, y plus offset y, and if that cell is alive, then it counts towards the total that we are adding up. So we have a count adjacent black tiles method that works there. So now we are gonna build a method which is a public IEnumerable of int x, int y, list tiles to flip. And so this thing is gonna do our... Did I ever build a loop that scans the entire grid? I did, it's down here. So we'll grab that loop there. X equals that, Y equals that, var count equals count adjacent black tiles, X, Y, and if, what were the conditions? If the black tile has 0 or more than 2 white tiles. So if, let me grab that line there. So first of all, we got that, and then we've got that. So any black tile, so if cells X, Y, so if this cell is black, let's flip that one. So what was our rule? We start out with white, and when cells get flipped, they go black. So cells X, Y has to be true, then else we run the method on there. So if cells X, Y is there, any black tile with 2 or any black tile with 0 or more than 2 black tiles immediately adjacent to it. If count equals 0 or count is greater than 2, yield return. So yes, we want this to be included in the list of cells that are going to get flipped next time. Otherwise, any white tile with exactly 2 black tiles is going to get flipped. Yeah. So if count equals 2, yield return x, y. Yep, that should be fine. That should be fine. That'll count the adjacent tiles. That works, and that's drop that in there. That makes that look a little bit nicer. So we got list tiles to flip, and then we want a public void play game of life, and that's just gonna say, so first of all, we can calculate list tiles to flip, but we need to do that in a 2 list, and yeah, we need to grow the we got a +1, -1 thing scanning the grid. This is tedious. This feels like solving the same problem again in 6 axes instead of 4. So x equals what were the origins of our puzzle? Um, all right. This thing's got to expand by 1 every time, because we need to include cells that were not included last time we did this. So let's just do a private int x min equals 0, private int y min equals 0, private int x max equals 0, private int x max equals x y max equals 0 equals 0. That's right. So now we gotta do this whole thing. That's our count. That's our, so the first round we gotta do as we flip a tile. Each time we flip a tile, we gotta work out what the new x and min coordinates are. So when we flip tile, flip tile, flip tile, flip tile. Calculating min-max before each iteration is sufficient. The input is small. You don't need to grow it on flip. I just need something to start it with. I need to know the seed value to start with. So... So when you say start with the first element, Adam, so we got this grid that needs to get really, really big, because our 128 grid isn't going to be big enough anymore. That needs to expand. And we got a two-dimensional array, yeah, with 0, 0, but then on the first scan, all of the other tiles that were flipped by our first iteration are going to be outside the scope of what we're looking at in the scan, right? And it's not actually that. It's the origin cell is going to be the thing that does it. I'm just going to fudge it. I'm going to plug in some numbers and I'm going to see what we get. And I'm going to assume that our... So honeycomb here is going to be... let's make that 8192. And I'm going to say origin here is going to be 4096, 4096. Okay, so... so private int game size equals I'm gonna start that at 32, which is probably, I was gonna 64, that's probably big enough. So all these can come out. So then for var x, so x is gonna start at origin dot x. You calculate size right before the scan. How do I calculate the size if I haven't been keeping track of which tiles I flipped previously? So x minus game size. Let me try this. X is less than origin.x plus game size. Okay, when you say iterate over all the items you have, I've got a huge grid of bools, because that's what I've got here. I've got this line here that says cells equals new bool size, yeah? So either I iterate over everything I've got, in which case it's not going to get any bigger, because that's how big it was, and I'm never dynamically reallocating the array to make the array bigger, Or I need to scan a subset in the middle and kind of grow that as we go. Let's hang on. Let's just try this. If I make the thing big enough, yeah, it's not that big, really, is it? So x equals 0. Let me grab the loop syntax we got off the bottom there. If this is horribly slow, I'm using an array, not a hash set. Yeah. So play game of life. So this is going to be, yeah, massive grid with an extra 100 in each direction. Well, I got a massive grid with an extra 4,000 in each direction, which may be too small. Or 100 iterations. So play game of life. So this is going to be what? This is going to be play a single move. So, yeah. Can't grow more than one each time. Play single round of game of life. And my original one there was how big? 64, was it? So I can probably get away with making that 256. 256. Int size equals origin dot x times 2. Will that? No, that won't work because it's not a compile time constant, is it? 512. Yeah, that should be right. Yeah, x naught. So play single round of game of life. For each var flip in list tiles to flip dot to list, because I need to do that first. Cells flip dot x flip dot y equals not cells flip dot x flip dot y. No, that's all right. Yeah, what? Yep. So what do we think here? Do we think this is going to work, or do we think that we are in for... Now, oh, they gave us some test data, didn't they? The above example, 15, so that should be all right. So I can run some tests against this stuff. That's based on their example input, wasn't it? Which is this one here, fliptiles.example. So test public void test game of life on example input. Var hc equals new honeycomb. Yep. hc.fliptiles example. That's fine. Then after a given number of days, so hc.play single round of game of life, hc.count black tiles should be 15. It's not. Why is it not? Index was outside the bounds of the array. I need to do a x equals 1 and y equals 1. I do not want to scan beyond the bounds of my grid. Cool. Test passed. So test and 12, 25, 14. So var expected equals new int, and we're expecting 15, 12, 25, 14, 23, 28, 41, 37, 49, 37. Okay, flip tiles dot example for each var int in expecteds. No, that's not it. For var c in expecteds. Visual Studio has encountered an unrecoverable error. We recommend saving your work and then restarting it. Nah, feeling lucky. Cool. All right. So that crunched that lot. So let's now just check the so day 10, 20, 30, 40, 50, 60. Right, let's throw that in and just see if that's going to work. Public void test game of life times 10 on example. Input var expecteds equals new what do we got? 37. Does full-blown VS not have a block cursor mode? Oh, there we go. That's what we want. Alt drag. Yep. Yeah, that's cool. All right, that worked. New. Okay, that int is redundant. HC equals new honeycomb. HC.fliptiles on example. That's fine. And then for each var c in expecteds. HC.play single round a game of life. We gotta do that 10 times, don't we? If this was Ruby, I could say 10 times that, but we can't. So let me just check. So we got one. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Simplest thing that'll make the code pass. It's running. Kick that and run that again. I'm going to close and restart Visual Studio because of this warning saying that it might have blown up. Well, that is very dead and unresponsive. Okay, there we go. That's doing something. Okay, those tests are green. It's saying that they're slow, but they're green. Okay. So they just want to know, after 100 days, what have we got on our real puzzle input, right? Public void solve part 2, honeycomb, file.read all lines. That's going to run our input. Then we want a for var I equals 0, I is less than 100, I plus plus, hc.flip tiles. No, hc.play single round of game of life. I think that one I'm going to comment out. Yeah, that's now taking longer to run than and Crunch is entirely comfortable with. Let's just check. I might need to crank up the test timeout or make this go faster. Where's the test timeout setting on here? So we've got a Yep, I may actually need to just fire up a console application to be able to run that last test. Or I may need to optimize the code and make it less intensive. Yeah, it's timing out. Okay. Yeah, timeout expired. Unignored test with a long running time because that's okay. All right. So let me just go and say add new project. Ding. Console app, .NET Core, next one of those. This is going to be day 24 code. And we're going to grab input.txt and we're going to copy it into our code project. Copy always to output. And then program.cs, we're going to jump into our test. We're going to grab our solve part 2, we're gonna drop that in here and we're going to do hc equals new honeycomb. Reference date 24 tests, that's fine. We don't need that. Console.writeLine hc.count black tiles. And just to make this a little bit more interesting, we're doing this 100 times, so a console.writeLine in here will be nice and cheap. After 4070. Cute. Let's see if it's correct. That is the right answer. You are 1 gold star closer to saving your vacation. That was fun. That was nice. That was kind of cool and yeah, entertaining. As Johan said. Yeah, that was kind of good. An hour and 45 minutes as well. Now, I just wonder, I'm just going to check one tiny little thing here. How long did that take? So if I jump over into that one, that equals that, chop that out, chop that out, chop that out. That one drops in at the end there. Console.writeLine there. We run that 100 times. Var SW equals new stopwatch in system.diagnostics, SW.start, run it 100 times, SW.stop, console writeLine there, console.writeLine took plus SW.elapsed milliseconds plus MS. Okay. Run that. 7.4 seconds. So I want to go over into my honeycomb project here. And what I'm going to do, I'm just going to implement that optimization where we keep track of our minimum and maximum. So private read only. Int x, int y, min equals, and I'm going to start off by making that 0. So that's going to be 256, 256. And I'm going to say private read only int x, int y, max equals 256, 256. Okay, and then I want in the flip tile method. This one I just need to expand the thing every time. So if x is less than min.x, min.x equals x. If x is greater than max.x, max.x equals x. I want to move to only keeping black tiles, loading up the current. Yeah. No, I think we can probably get some. Those shouldn't be read only. Those need to be mutables. And if y is greater, if y is less than min.y, min.y equals y, and if y is greater than max.y, max.y equals y. So that should grow all of those nicely enough as we go through, flipping all the tiles. And then I'm going to say for x equals min.x minus 1 and y equals y.min minus 1, min.y minus 1. X is less than max.x plus 1 and y is less than max.y plus 1. For that, and then min.x minus minus, min.y minus minus, max.x plus plus, max.y plus plus. Yeah. Sped up by a factor of 10. So it went from 7,400 seconds to about 600 milliseconds. I'm happy with that. And I'm going to wrap it up because I've got stuff to do, because I'm throwing a party on the internet on Sunday and you're all invited. And in case anybody has not seen the details yet, it is go to this web address that I am about to put in the chat. Which is gonna be fun. Let me bring up the social media thing that I have for it, because that's a thing that apparently I do now, which is https://dylanbt.net/holodeck. There, look at that. That's what we're doing. So yeah, it's on Sunday, kicking off 7 o'clock UK time. It's going to be a couple of hours of just fun, musical, nerd, comedy, jokes, and there's going to be a bunch of songs. There's going to be a... That's some excellent Photoshop skills right there. Thank you, Louise. The SVG Santa hat is the bit that I'm particularly proud of. So yeah, I'm doing that on Sunday. And what I suggest folks do is, if you want to get a bunch of friends on a Zoom together, and then you can all be on Zoom and you can be watching me on Twitch and talking to each other on Zoom and stuff, that will turn it into... Because when you go to a real party, it isn't like everyone all talks to each other at the same time. It's people break into little groups and stuff, and I'm trying to figure out how to replicate that. And I think little me streaming live and doing all my stupid stuff and people watching it in little Zoom bubbles and stuff. So yeah, also Lionel will be there. This is Lionel. Lionel the cat being derpy, and he will almost certainly show up at some point. Anyway, thank you very much for tuning in, gang. Tomorrow morning is Christmas Day. Happy birthday to Jesus. So I'm gonna be doing Advent Code tomorrow in the morning to get it out of the day, because by 4 p.m. I plan on being substantially too inebriated to be allowed to write program code on the internet, because it's Christmas and I've got lots of very nice beer, and I continue to be shocked by the passage of time, says Louise. I know, it's like 24 hours a day, every day. No, the Balmer Peak is... I used to kind of, when I was a student, find occasional moments of wonderful productivity when I was... had a couple of beers and stuff, but these days I tend to find that if I'm trying to actually accomplish anything, it doesn't really help. Having a couple of drinks I find is quite nice for songwriting and, writing prose and that kind of stuff. But actually, I think the older I get, the brain cells that are good at doing stuff when they've had beer are dying out, and the brain cells that are left are like, no, please don't do that to us. So the survival of the fittest of the human brain cells. Anyway, yeah, so tomorrow I'm going to do it early. So I might see some of you, if anyone's on. I have no idea, anyone who actually streams in to me doing Advent Code on Christmas morning. But the kind of year that we've had, it actually wouldn't surprise me if I get a couple of people on. And then, yeah, keep an eye, join the party on Sunday. How early is early? Probably about 10 o'clock in the morning. I want to be finished by about noon. That's what I'm shooting for here. So, and then I'm going to have a nice big lunch, and I'm going to feed Lionel some roast duck and Czech dumplings. Kledniki, the dinner this year is Eastern Europeans. Roast duck, dumplings, red cabbage, braised with apple and cider, and nice beer, nice wine, and then I'm hosting a Zoom quiz with my family at about 6, which should be... someone said Christmas Day challenges are usually easy. You know what? If it's not, I'm not going to beat myself up. I'm going to give it a couple of hours just for the sake of completing the thing. Yeah, that's what we're going to do. And it's going to be fun. And then, yeah, tune in Sunday, throwing a party, music and comedy and silliness and all that kind of stuff, which I need to go and keep preparing for now, because I have all kinds of fun things to put together for that. And then probably between Christmas and New Year, going to take things a little bit easy. And then January, I'm going to come up with something else, and I'm going to try and stream. Not necessarily every day, but I'm gonna do a regular thing a couple of times a week and see how it all goes. So so if you don't tune in tomorrow, happy Christmas, everyone. Thank you very much for tuning in and watching. It's been really, really good fun hanging out with all of you these past couple of weeks and solving the Advent of Code puzzles. Yeah, have a great Christmas. I'll see some of you Sunday. I'll see some of you soon. And let's find somebody to raid. Let's see who's online. Channels I follow, there are literally none of my followers is streaming. Alright, I'm just gonna stop. Thank you for tuning in, gang. It's been a lot of fun. See you all soon. Bye-bye.